All right. Now we're going to look at problems where we have to find the sum of an infinite geometric series. So this first problem, we have the infinite geometric series with the, equation for an is equal to 60 times 1/10 to the k power. Again, don't worry if it's k or n or j. That is not really a big deal. At least not until you get to like advanced calculus or something. It's just the notation they use in different textbooks. So for this, we can just simply use an equation or formula for the infinite sum, which is going to be equal to a1, or the first term, all over 1 minus the common ratio r. So this is actually easier to calculate than partial sum. I'm not going to go into why this formula works in this video, at least. I'll go over it in my lesson video in case you're curious. So let's just practice using it. So in this case, we want to find S infinity, or just whatever this is. This is the same symbol for, the sum of the infinite terms. We'll have S sub infinity be equal to A1. A1 is just going to be the value when you plug in 1 into the equation. So in this case, A1 will be equal to 60 times 1/10 to the 1, which is just 60 times 1/10, or 60 tenths, which will just be 6. So we'll have 6 on top, and this will be all over 1 minus the common ratio, which is going to be 1/10. Because remember, the common ratio is going to be the value that you're multiplying repeatedly, or the power, or the base, that's being raised to a power. Usually it'll be in parentheses when you have geometric series, but don't expect it to always be in parentheses, because sometimes they just may disguise it some may just disguise it in a different way, but it's the same principle. So 1/10, and all we have to do is simplify this. This will be 6 1/10 taken away from 1. 1 is the same as 10 tenths. Those will be just 9 tenths. This will be equal to 6 over 1 times 10 over 9. And this will just be same as 60 over 9. Dividing both by 3, we'll get 20 over 3. I prefer, at least for my students, that they leave their answers as a fraction. You're going to get a repeating decimal if you do this in your calculator. You'll get 6.6 repeating, which I just don't like. It's better to keep it as a fraction because they're more exact. Most teachers will prefer that. Let's do one more. And let's look at the case when we're not given it just in this form, when we're given it just as the sequence. So we have 8/5 minus 4/5 plus 2/5 minus 1/5, da da da. So first, let's find our common ratio. And we can do that by dividing any term. Let's take negative 4/5 by the previous term, so the term before it, which is 8/5. And this will be negative 8 over 4, because we'll have negative 4/5 multiplied by the reciprocal of 8/5, which is 5/8. The 5's cancel. 4 is reduced. We'll get negative 1/2. And then we just use this equation for the infinite sum. So S infinity will be equal to A1, which is going to be 8/5 in this case, all over 1 minus R, 1 minus -1/2. So just don't mess up on your fraction math. This will be 8/5 over 1 plus 1/2, or 8/5 over 2 halves plus 1/2, which will be 8/5 over 3 halves. Simplifying, we'll get 8/5 times 2/3, which will give us 16 over 15. And we can reduce that. And so that'll be our answer. That's all there is to it. So I hope that helps. If it does, please subscribe and give me a like. I'll see you guys in the next video.